This is a video to help you see how to solve question 6 from section 11.5. And in this particular question, we are asked to calculate two probabilities for transistors. And we have 14 transistors, 5 of them are defective, and we're selecting 5 at random. We're asked to find what's the probability that all are defective. Well, since we're selecting 5, that would be abbreviated as the probability that we have 5 defective. And since order is not important in the selection, we will be using this combination formula from a prior section. And if you have trouble with the formula, let me know, because I can send you another video. Probability is always the ways that the event will happen over the total possible. So in this case, we want to count up the ways that 5 are selected defective over the total possible ways of selecting 5. So if we look at the combination formula, the bottom is easier, so I'll start there. We have 14 total transistors and we're selecting 5. So the total combination of ways to do that would be this combination. The top is usually the trickier one, and so in this case we are selecting 5 and we want to know what's the probability that all 5 of them are defective. Well, there's only 5 that are defective in the set, so there's 5 that are defective and we're selecting 5. So in this case, both N and R are 5. If you have trouble getting these, let me know, and I'll show you the steps to get from here to here. But if you calculate the combination of 14 transistors and we're selecting 5, you get 2002. And then if you have 5 defective transistors and you're selecting all of them, all 5, there's only one way to do that, and that's to select all 5. So please tell me if you don't know the steps between these two. So the answer is 1 out of 2002. In part B, we're calculating the probability that none of them are defective. So that's the probability of selecting 0 defective transistors. Again, probability is always the ways to have the event occur over the total possible. So here we're asking, what are the ways that all 5 are good? Or the same question might be that 0 are bad, but mathematically that doesn't make the formula work. So we want to have 5 good transistors over the total possible. So the denominator is the same number that we calculated up here. It's still the same total possible. So 14 transistors, we're selecting 5 of them. There's still 2002 ways for that to occur. This is really the trickiest part, is to recognize that in this case, since we have none of them are defective, that means out of the 14 total, there's 9 good ones that we want to pick 5 of. So the 9 is the tricky part, is to realize that here we're looking for the 5 good transistors, so there's only 9 of them if out of the 14, 5 are bad. Again, if you don't know how to get from here to here, tell me and I'll show you the in-between steps in another video. 126 over 2002 simplifies. I notice that they're both even, so I first divided out of 2. And when you get to 63 over 1001, I realize that 63 is not a prime number, so I start testing the numbers that divide into 63 and 1001. And I realize that 7 divides into 63, so 7 also divides into 1001. So the simplified answer is 9 over 143.